These are the four parameters or basic properties of a gas. There's pressure, we use capital P, volume, capital V, temperature, capital T, and we measure the amount of gas in moles, and that's given the symbol lowercase n, just because. Those properties are interrelated. When you change one, at least one of the other ones has to change. So there are what we call simple gas laws, and these are simple because they just look at the relationship between two of the properties. You do that by holding the other ones constant, so just allowing two of them to change. So these laws were deduced from observation a very, very long time ago. The first one we'll look at is Boyle's law. Robert Boyle lived back in the 1600s, and he was playing around with liquid mercury. So he had a J-shaped tube, and put a stopper here. Now I've trapped some gas in there. If you add more mercury to this side, you will increase the pressure on the gas and the volume gets smaller. So here he's measuring the difference in pressure between the gas and the atmosphere, and you can measure the volume. You can even do it with just some geometry, volume of a cylinder. And here, by adding more mercury, it's pressing this gas, pushing on it, making it smaller, compressing it, and the pressure difference is larger. So he looked at this. We call this an inverse relationship because if the pressure goes up, the volume goes down, and vice versa. So this is what some of his data might possibly have looked like, where we graph the volume versus the pressure. So we're changing the pressure by adding mercury, and then we're measuring the volume, and you get this curve. So what's known as Boyle's law is often expressed as P1V1 equals P2V2. The volume is proportional to 1 over the pressure. If the pressure gets bigger, volume gets smaller. But the pressure times the volume is equal to a constant. So if you change the conditions, that constant is the same, assuming that your temperature and amount of gas haven't changed. So we get P1V1 equals P2V2. If we graph volume versus pressure, we get a curved line. If we graph volume versus 1 over pressure, we get a straight line. So this is just looking at the volume as a function of pressure. If we take those pressures and invert them, 1 over, and use those as our x-coordinates, we get this lovely straight line. Molecular interpretation. Here we have a piston assembly. So this is a chamber that we can change the volume of by moving the ceiling here. And we've got a little pressure gauge here. So we got 10 gas molecules in here and a certain amount of pressure on here. And this is equal to, what's that equal to? 1 atmosphere? Yeah, this is that right there. 1 atmosphere, the volume is 1 liter. So if we put a heavier weight on the ceiling and add more pressure to this, you can see the pressure went up to 2 atmospheres. We doubled the pressure, the volume gets cut in half. So the pressure got multiplied by 2, the volume got divided by 2. And that's that relationship. If you're scuba diving, and obviously you're going underwater, I was going to say if, but that's dumb. So as you go down deeper and deeper into the water, water is more dense than air, and it applies more pressure than air. So here up at the surface, you're experiencing a pressure of 1 atmosphere. For every 10 meters you go down, it increases another atmosphere. So here at 10 meters, you'd have 1 plus 1, or 2 atmospheres of pressure. You go down to 20 atmospheres, you've got 1 plus 2, or 3 atmospheres of pressure. And that's why snorkeling is, scuba diving is a bit complicated because of there's a lot to consider in terms of the pressure of the air tank and stuff. If you were to hold your breath down at 20 meters and then pop up to the surface very quickly, your lungs are going from 3 atmospheres of pressure to 1 atmosphere of pressure on the outside, but there's still 3 on the inside. There's going to be a massive expansion and there would be damage to your internal organs. Yeah, you could pop your lungs. So, one of the things they say is always exhale when rising. Don't hold your breath. As long as you're inhaling and exhaling, because your tank adjusts the pressure for you, you'll be fine. Because as the pressure outside decreases and the pressure inside is high, then it's going to want to expand. Okay, this is their example. I think it's a weird one to start with, but whatever, that's what they gave us. This is a story problem with way too much story. A snorkeler takes a syringe filled with 16 milliliters of air from the surface, where the pressure is 1 atmosphere, to an unknown depth. The volume of the air in the syringe at this depth is 7.5 milliliters. What's the pressure at this depth? And we'll work on the other question later. So they're asking what the pressure is, and they gave us 16 milliliters and 1 atmosphere and 7.5 milliliters. This is a problem where it might be helpful to draw an ugly picture. So we have some water. That's water. Kind of looks like water. And we have a syringe. So here's our syringe. It's closed at one end. And there's the plunger. And this is telling us that there's 16 milliliters of air in it up here. So the volume of the syringe is equal to 16 milliliters. And then the snorkeler takes this down. We don't know how far, but takes it down. As it goes down, the pressure increases because of the water. And so the pressure is pushing on this. The sides of the syringe can't move, but the plunger can move. So it's pushing on the plunger, much like you taking a closed syringe with air in it and pushing on it. You can push on it and compress the air, right? So as you take this down, what happens is the plunger gets pushed in. So down here, we are told that the volume is 7.5 milliliters. What's the pressure up here? 1. Pressure up here is 1. They told us that. 1 atmosphere. So these are the 3 numbers they gave us. And they're asking us for the pressure down here. We're going to use Boyle's law, not only because it says Boyle's law in the title of this problem, but because this is the law we need to use. P1V1 equals P2V2. So this volume and this pressure go together. You can call it 1 or 2, doesn't matter as long as you pair them up correctly. I'm going to call it 1 because I think of it starting up there, and that just makes more sense to me. And then down here, this would be volume 2 and pressure 2. So the pressure is what I'm trying to find, this guy. P2 is what I'm trying to solve for. These problems sometimes involve dimensional analysis, but they're not solved primarily with dimensional analysis. We're going to use equations. Rearrange the equation to get what you're looking for by itself. And if you don't remember this very well from algebra, I'll be happy to refresh your memory. We want to get P2 by itself. We can get rid of V2 by dividing. We divide both sides by V2. The V2's cancel out. So I end up with P2 is equal to P1 V1 divided by V2. It is super easy to get those 1s and 2s mixed up. So make sure that you're copying them down correctly. Now I can put these numbers in. Pressure 1 is 1 atmosphere. Volume 1 is 16 milliliters. Volume 2 is 17.5 milliliters. The milliliter units cancel out. So I've got 16 divided by 7.5. So pressure 2 is equal to 2.133 atmospheres. So the answer to the first question is the pressure is 2.1 atmospheres. Any questions about that one? The second question, if the pressure increases by 1 atmosphere for every additional 10 meters of depth, how deep is the snorkeler? Well, started at 1 atmosphere, and down here we're at 2.1 atmospheres. So it's a little past 10 meters. This is actually a conversion factor. 1 atmosphere equals 10 meters of depth. So the pressure increases. So I have the pressure down here is 2.1 atmospheres. The pressure that I started at was 1 atmosphere. Did this wrong yesterday. So I've had an increase of 1.1 atmospheres. That's the increase in pressure. I get an increase of 1 atmosphere for every 10 meters. Every 10 meters gives me 1 atmosphere. So that tells me this guy is at 11 meters deep. This is the sort of thing that, I think of Swiss Family Robinson or somebody getting stuck on an island, right? And for some reason they need to measure how deep something is. And they have a syringe, and you could figure this out by looking at the volume on the syringe at the surface and taking it down there and seeing how did it change. And you could calculate how deep that was. Anyway, any questions?